Yeah, dear student, now there is another question here. A convex lens of focal length 20 centimeter is placed coaxially with convex mirror of radial curvature 20 centimeter, 15 centimeter away from the mirror. An object is placed at distance 40 centimeter from lens. Find the position of image and draw the diagram also. Convex, now I am drawing the diagram. Convex lens. Convex lens, focal length 20 centimeter. And convex mirror are placed coaxially. This distance 15 centimeter. Its R is equal to 20 centimeter, so F is equal to 10 centimeter. Object placed at 40 centimeter from here. So you are asked what is the final image? हमारा फाइनल इमेज कहाँ होगा? Where will the final image? Simple matter, but the student get confused. So we are solving mirror also. For lens, U is equal to minus 40, F is equal to 20. तो बेसिकली क्लियर है कि इट इज ए 2f पे में 2f 40 सेंटीमीटर बनाएगा इधर नहीं, बट यूजिंग लेंस इक्वेशन 1/v minus 1/e equal to 1/f 1/v minus 1/40 1/20. तो 1/v 1/20 minus 1/40 40 LCM 2 minus 1, तो v कम 40 सेंटीमीटर 40 सेंटीमीटर, ये 40 तो इधर इतना ही 40 यहाँ कहीं होगा. दिस इमेज formed by convex lens will act as object for convex mirror. This image will act as a virtual image, virtual object for convex mirror. So, for convex mirror, U equal to 40 minus 15 is equal to 25 centimeter. Now, 25, its radial curvature 20 तो 25 पर बना दें यहाँ पर ही ना 40, same distance. Yes, it may be here 40. And this distance now 25. C is at 20 here. ये C होगा. So from mirror equation, you know, mirror equation 1/v plus 1/u is equal to 1/f, and hence 1/v plus 1/25 is equal to 1/10. For convex mirror focal length positive, so 1/v is equal to 1/10 minus 1/20. 20, 2 minus 1. Something I wrong. What is wrong with me? mirror equation 1 upon b plus no, it is 25, sorry. It is 25, sorry. 25. So LCM is now 50. So 5 minus 2. So that way we get b equal to 50 upon 3. Nearly 18.6 centimeter. Where will be 18? Somewhere here. तो हमारा इमेज जो बनेगा वो वी कैन शो लाइक दिस डायग्राम। ये यहाँ पर 25 पर मिलती है ऐसे, लेकिन इमेज बना यहाँ। इसका मतलब क्या होगा कि रे आफ्टर रिफ्लेक्शन वो मिरर रिफ्लेक्स, तो ये ऐसे यहाँ पर डायग्राम है। सिमिलरली दिस साइड आल्सो you can have this ray here, but image here, so this will be the diagram for, I think you have got my point, or should I draw again? मैं डायग्राम फिर दोबारा बना रहा हूँ, क्योंकि वो ये कॉन्वेक्स लेंस और फोकल लेंथ 20 सेंटीमीटर, convex mirror at 15 centimeter from this, the distance 15. Object placed at 40 centimeter. 40 centimeter. Its R is 20, so focal length 10. So this object O is at 40, means at 2F. So image will be at 40 centimeter here, like this. But we have got v at 50 by 3, तो अगर ये हमने बैठा था 40 तो ये बैठा 50 25, C is there 20, image less than 20 here, so it means they have after reflection will appear to come from this point. Here is the final image I dash virtual object. Similarly, from this side, you can have like this, and these will have reflected from this point. So this question was there in board exam. Please be sincere and work hard. Try to understand problem. Watch the video very concentrately, and then do the solution yourself. Ray optics numericals are generally asked in ray optics. The same year when this question came in board, I gave another question here in pre-board. The same year, we in class 12 pre-board is given to students. So in that exam, I asked question. It is convex lens, it is concave mirror placed coaxially. An object is placed here. I gave this distance as suppose 5 centimeter. And focal length of this is 20 centimeter. If an object is placed at distance of say 40 centimeter, then image is formed here again. We place object at 40 centimeter from this convex lens, and when we place this mirror at 5 centimeter, image is formed on the object itself. Find radius of curvature of this convex mirror. ये क्वेश्चन I gave in pre-board exam. So when this image will be here only, if ray after refraction fall on mirror in such a manner that they follow the path back, then it is only possible. And the ray falling at any mirror is reflected back on the same path. If it is falling normally, it means these rays falling here normally. And if we produce them back, it means they are going to center because radius perpendicular tangent. Radius perpendicular tangent. And when they fall normally, they are reflected back. So it is only possible when if image is formed, real image होगा नहीं, inverted है. It is possible if a ray after refraction from this lens fall normally on the mirror, and ray falling normally will be reflected back, and if they fall normally, then they appear to come from center curvature. Since this is 40 centimeter, so this distance is also 40 centimeter. Why? Focal length 20, object distance 40, so object placed at 2f, or you can use mirror lens equation also. So this is 40 and this is 5. So R is equal to 40 minus 5, यानी के 35 centimeter is the radius curvature of this mirror. This is a method of finding the focal length of convex mirror in lab also. By in case of concave mirror, you may get real image. But in convex mirror, for every real object, image is virtual. And position of virtual image cannot be taken on screen. So how to find the focal length of convex mirror? So we put the mirror and the lens coaxially, put the object at certain distance from the lens so that image is there. To find focal length of convex mirror, using convex lens, we place convex lens and convex mirror coaxially. And remember, in a lab, a lot of difficulty are faced. They should be coaxially. If mirror is like this and lens is like this, then it will not be obtained. We have to adjust to see the image of this object formed by this combination. So when you get parallax removed, means image is obtained on the object itself. Then ray after refraction from lens falling normally. If they fall normally, it means they appear to come from C. And since focal length of this lens 20, here in this numerical, so image will be at 40. So in lab, what you will do now? ये image मिल गया. Now replace the mirror now. By it is at 40 centimeter. So image will be at 40 centimeter. So put the another image pin and get the parallax removed. And that way, here it was there 5 centimeter 40. So you can find out R and F is equal to R by 2. So you can find out focal length of convex mirror using convex lens in lab. I am repeating again, we put convex lens and convex mirror coaxially, put an object here and get the image from at the object itself. It is only possible if ray fall normally here. If they are falling normally, it means they are getting at C. So to find this position, we remove this without changing the position of lens and object pin. And we will see the image of this object now here. And put the image pin here below it, get the parallax removed, you will get the distance. So this is a practical of finding focal length. Dear friend, you must go to lab. Lab is very important place where you learn so many things. Now, there is another question here. Power of two lenses are 3 diopter and minus 5 diopter. There are two lenses, power P1 plus 3 diopter and P2 minus 5 diopter. They are placed coaxially in contact. They are placed coaxially in contact. An object is placed at distance of 50 centimeter from the combination. These two lenses are placed in contact to form a single lens. Power 3 diopter means plus 3 means convex, minus 5 means concave, like this. They are placed like this. So what is the combined power? P equal to P1 plus P2. Object placed at 50 centimeter from here. So where will be the image? So power 3 plus minus 5 minus 2 diopter means this lens will behave a concave lens. Combination will be concave. And F is equal to 1 upon D. So 1 upon P, sorry. So 1 upon minus 2, यानी कि minus 0.5 meter or 50 centimeter. Minus 50 centimeter will be the focal length of combined lens. First you find the focal length of combined lens. Object at 50 centimeter. This lens behaves concave lens. Focal length minus 50 centimeter. From lens equation 1 upon B minus 1 upon U equal to 1 upon F. 1 upon B equal to 1 upon F plus 1 upon U. It is minus 1 upon 50. It is also minus 1 upon 50. So it is minus 2 by 50. So B is equal to minus 50 upon 2. Minus 25 centimeter. So virtual image will be there. So there are many questions like this. There is another question here. Power of a lens. A lens has power 5 diopter plus 5 diopter in air. A lens has power of plus 5 diopter. What will be power when immersed deep in water? इस लेंस को अगर पानी में डुबो देंगे, है भाई, तो what will be power? Reflectance of glass ANG 1.5, ANW they have given 4/3. So what will be power? So power of this lens in air, since power in air 5 diopter, so F is equal to 1 upon 5 meter, यानी कि 20 centimeter in air. Focal length in air is 50. To find focal length in water, for that I have told you F dash equal to n minus 1 into n dash upon n minus n dash into F. What is n? 1.5 minus 1 into n dash 4 by 3 upon 1.5 minus 4 by 3 into this is 20. So it will be 0.5 into 4 by 3 upon 4.5 minus 4, 0.5 by 3 into 20. So 0.5 by 3 cancel. So this f come out f dash 24 ja 80 centimeter. 80 centimeter. The focal length of this lens in water is 80 centimeter. So P equal to P dash या P in water 1/f in water यानी कि 1/80/100 because we have to put focal length in meter, then only you will get power in centimeter. It is 5 by 4. 5 by 4 means 1.25 diameter. I think you have got my point. So, dear friend, please try more numerical yourself from different books. I will be solving 2 or more questions there on this ray optics. Thank you.